Welcome everybody, welcome at this presentation with a rather long title, Tool Life Maximization Through Smart Tool Life Cycle Management. Now Tool Life, the technical people here, that I suppose you know what Tool Life is about. 10 minutes, 15 minutes cutting time before we index the cutting edge. That's Tool Life. Tool Life Cycle, and throughout this presentation, the word life cycle, I kind of make a mistake against the English language here. I make it one word because I want to make a difference between tool life and tool life cycle. Tool life is something we count in minutes. It's the cutting time before a tool is worn out and we have to index it. A tool life cycle is about the road, the path that a tool takes from beginning till end, from the moment it is selected for a process till we decide to throw it away or to recycle it. That's a tool life cycle. Tool life is a technical thing. Tool life cycle management is more about an organizational thing, a logistic thing, a management thing. Now, maximizing total tool life, and I already start here with a word which is perhaps a bit new for you, total tool life. Total tool life is something we use in the terminology of tool life cycle as the sum of all the individual tool lives the tool had for an application in its life cycle. So we want to maximize that. And that means that we have to look beyond only one aspect in a tool life cycle. Normally we focus on the usage. A tool is cutting, a tool is in use, and we focus on that. But if we want to talk about the total tool life, then we have to see the total picture of what a tool is doing in a company. That means we have to see from the selection, when do we select a tool, where do we select a tool, till the moment we decide to stop using the tool because it's totally worn out. So we have to have a broader look. And I already said it's about selecting, it's about using, it's about indexing. Next to that, it's about storing tools, it's about doing maintenance on tools. All of that are different steps in a tool life cycle. And here, perhaps, I want to focus a little bit more on not exactly the usage, and perhaps this is going to, for the people, the technical people, they think, yeah, if it's not about how to use a tool, then this is not a subject for us. But I would say, stay a little bit longer in this presentation, give it a try, because I'm going to put usage of a tool in a broader perspective. And I'm going to spend quite some attention to things like storage and maintenance and so on. And perhaps you ask for yourself, why about that? What is so special about maintenance and storing and that type of stuff? Well, because my experience is that if you have a look at what people are doing with cutting tools in a production plant, that a lot of focus is on the usage, and all the rest is a bit, perhaps neglected is too strong a word, but let me show you some photos, let me show you some pictures I took when I was somewhere in a workshop. This is how people store tools very often. Most probably a lot of you now say, yeah, not in my workshop, and of course not in workshop. This is always happening in another workshop, but it is reality. And you know, handling tools from a maintenance perspective, from a storage perspective, the way you see here illustrated by the photos has consequences, and serious consequences. And I want to talk about those things. My name is Patrick de Vos. I'm your host today. I'm quite a big number of years in the machining industry. I worked for the majority, nearly my full career, I was employed by Seco. Now since last year I'm retired, but you know, retiring doesn't mean losing interest in something that was a passion for the whole of your professional life. So I continue to do things, and I'm of course not alone here. There are other people in the team making it possible that all of this happens. You know, they are behind the scenes making things happening here. And we are broadcasting, perhaps interesting for you to know, we are broadcasting from the office, the SECO office in Germany. And within a couple of weeks, they have a very big event here. A live event, and those who are somewhere around here in the neighborhood, I would suggest you join the event. It's quite an interesting thing. But back to the presentation now. The agenda looks rather up to point 4, rather traditional. We are going to talk about what is tool life cycle, how do you manage a tool life cycle, and all that type of stuff. But as from the 5th point on, I want to spend extra attention to a number of things very often neglected in this context. The selection of tooling, and I'm going to show you how versatile tooling, which very often from a technical perspective is the last option people consider, I would put it as a first option. And I would like to explain you why. Clear instructions, because to make all of this happen, you know, because some people say, yeah, but all this, you know, we buy a software package and everything is arranged for. Now, the success of a successful tool lifecycle management structure, for me, is not in the software package you use or you decide to buy or whatever. The real success is in the daily work of the people working with the tools, the operators, the technicians, the engineers, the tool room people. They make a success out of this. And one of the things which are needed is that those people receive clear instructions. You know, if an operator asks you, when do I have to index a cutting edge? And your answer is, yeah, I don't know, the moment it's worn out, that's not a clear instruction. It's a correct instruction, but it's not very clear for the operator what he's supposed to do. And that brings me to the human factor. People in this respect are key for making it work. So those 3 points I want to spend extra attention to. A few words on small batch production, because in the industry you have mass production, big batches, and you have small batches. Mass production is, some people will not like me to say it, but it's easy life, I call it, and later on I explain you why. From a tooling perspective, I call it easy life. Small batch production is a bit more challenging. Small batch production is where you produce small batches of specific, unique workpieces. And most of the time, the quality demands are rather high and the delivery requirements are very, very sharp, fast deliveries. And things throughout time are not improving, because if we look around in workshops, variances are increasing, batch sizes are decreasing, delivery performance is every day again higher up in the priority list. We all face problems with knowledge and skills, shortages from people, sustainability demands are playing a role. So life in small batch is not the easiest life. And having production excellence, it's one of those terms production people like to do magic with. Production excellence. What is production excellence? There are very complex definitions. But for me, production excellence is as simple as whatever you do it better than your competition. That will be appreciated by customers. And that's what you want with a company. So be better than the competition is the message here. Of course, we need to specify a little bit more. Be better than the competition needs to be defined in terms of what. And that brings me to what I call the key, let's call it key performance indicators for a workshop. Is it about costs? Is it about productivity? Is it about lead time? Is it what is important? And also here a few words on people, because as long as things go well, everything is well. But the moment something goes wrong, you need people to recognize something is going wrong, and you need people that know what to do to handle that issue. But to recognize if something is going wrong, people need to know what the target is. So production excellence is only possible if people have the knowledge about how value is created for a customer throughout the production chain. Now, how do we work with that? How do we measure production excellence? There is one way of measuring, kind of. It's not foolproof, but here in the light of this presentation, machine utilization is giving you a good indication about how well things are going. Machines are switched off, which is the worst scenario. You have a machine and you don't use it. The best scenario is that your machines are running optimized machining processes. The more machines you have doing that green situation you see here in the picture, most probably the better your production excellence is. And one way of measuring that is what is referred to as overall equipment efficiency. What I'm going to tell you, my former colleague Olivier will perhaps not like my way of defining it. Is a much more scientific approach to it, but just for the sake of explaining a bit, your machine is available around 9,000 hours per year, 365 days, 24 hours per day. That's the availability. That's the total time the machine is there. And then if you look what the machine is doing, what you find out is that part of the time the machines are standing still in a planned manner, weekends, not having a second, third shift, that type of stuff. That gives you a planned available time. But that is not the time the machine is actually running and producing correct workpieces, because part of the time the machine is standing still due to setup, and that takes time. And especially in small batch production, in the total picture, that takes a lot of time, because every new batch you need to set up the machine again. Machines are standing still because there are unplanned problems, and you all know in machining we have a whole bunch of unplanned problems, ranging from long ships, vibrations, bad surface finish, broken tools, shipped cutting edges. The list is endless. But each time something occurs, it needs to be taken care of, and while doing that, the machine is standing still, and you are losing time again. And part of the time the machines are producing workpieces, luckily, but part of those workpieces we have to decide not to deliver to customers because there is something wrong with the quality specifications. In the end, there is X amount of time that a machine actually is doing what it is supposed to do, for what it is bought in the first place, that is producing correctly finished workpieces that are sellable to customers. Well, the difference between total time, total available time, and what we call available time is depending company by company, and the time effectively the machine is producing correct workpieces, well, the ratio between those two is what we call OEE. How efficient are you using your machine tools? So if we talk about manufacturing or production excellence, and you are wondering what would it be for me, I can give you the advice. Do some measurement on OEE, and I don't say it gives you a full picture, but it gives you a rather good idea how good things are going. Tool life. From here on, I would like to make a distinction between technological tool life and total tool life. Technological tool life, that is the thing we machining people are familiar with. You have an application, you have a cutting tool, cutting conditions, you cut and you see how long you can cut without having too much problems, so you need to stop and replace the cutting edge. That is what is referred to as technological tool life. The question, and perhaps the most difficult question in machining, especially in small batch machining, is when is a cutting edge worn out? When is a cutting edge, when there is a need for indexing it? And I always make a comparison. It's like the tires of your car. When do you change the tires of your car? You start with new ones and they are wearing out, and somewhere you will have to decide when to change them. And that is depending on the weather conditions, that's depending on the environment in which you are using the car. Is it in mountains or is it in flat country? That is depending on if it's raining or not, and that is depending especially to which extent you want safety and security, that you don't lose control over the car and crash it and hurt yourself. Well, with cutting tools, it's exactly the same thing. We should go on, we should use cutting edges till it's becoming too dangerous, we start to have too many problems with the tool, and we even risk to crash it. Because crashing a tool is a serious thing. People say, yeah, of course it's a serious thing because you need to buy a new tool and that's expensive. No, that's the least of your concerns. Because crashing a tool means losing a workpiece, hurting an operator, losing time because you have to check the machine and so on and so forth. So technological tool life is an important thing. There are all kinds of models we have to find out if you have a certain type of tool in a certain application, a material and cutting conditions, how long you can use the tool before the wear is becoming so big, so much that there is a danger that things start to happen that you don't want. And in mass production, this is easy. If you have to produce 100,000 workpieces, well, you try and you make tests for 100, 500, perhaps 1,000 workpieces. You find all the data and stuff. You create the model, like you see here, an example, and then you know in that application that you are going to run for the next months or years, how the tool behave, and the instructions for the operators are very simple. Every 5th workpiece you index a cutting edge, and every 200 workpieces you index the insert if it's an insert tool, and so on and so forth. Life is easy. Life is beautiful in mass production. In small batch production, however, life is a bit more difficult because then you have a situation. You could use the tool for 20 minutes, but after 5 minutes, the batch you need to do is over and done with. And then what do you do with the tool? You throw it away because the job is done, or you keep it, but then you have to keep it in such a way that for the next application you know how far the wear was, and so on and so forth. Here it's a little bit more difficult. And here, next to technological approaches, we need more numerical data approaches to find out where a tool is in a certain way, and so on and so forth. There is something what we refer to as global tool deterioration analysis to work with this type of thing. That's technological things. Total tool life, what do we mean with total tool life? Well, that is the full operational lifetime of a cutting tool seen supra the different applications you have. So if you use the tool first, let's not make it too difficult, in a steel application to produce 5 workpieces, but then you keep it, and the next is a stainless steel, 3 workpieces, and in the first part you could use it with 5 minutes, and the second it's another 7 minutes, and then you have a third application with it. And if you start to adding all those things up over supra to one application, that's when you start talking about total tool life. Total, full operational tool life. And this is not influenced only by technological thinking, but it's also very strongly influenced by how well, how should I say this, how good are your capabilities as kind of a machining bookkeeper that keeps all the things together and makes sure that you have a clear picture. Total tool life starts with selection of cutting tools, and it ends with that somebody decides we can't use this tool anymore, it's totally used out, so we send it in for recycling, or we throw it away. That is the total lifespan we talk about. And if you want to have that maximum, critical again is that in between different stages you have clear instructions for people for what to do next. And if all of that is done very well, what you see is that one could say it like this: if you would be the purchasing manager, and if you manage that the tools you buy, you spend your money on, are used in a company with a very good control of the total tool life, and not only technological tool lives application by application, that you will have to buy lesser tools over a year or whatever period you want to take as a reference. That is the big gaining of this. But to make it possible, there are some foundations that needs to be done or taken care of. Your tool selection process is the first step in total tool life. Is the first step in tool life cycle management. How do you select your tools? Because if you start from the beginning with the wrong tools, yeah, then all the rest falls apart. After selecting tools, it's about how are you using tools? How well are you using tools? How well are people keeping track of data in this respect? The next thing is after usage, how do you set up manipulating of tools, indexing of tools, sending back to the tool room, and all that type of stuff. Once tool return to the tool room, or in some cases stay at the machine, but they need maintenance, they need storage, they need perhaps reconditioning like solid carbide tools. And what about recycling of certain tools? Also that needs to be taken care of. And if you want to go for maximum total tool life, there are a number of things you need. You need objective indicators. For when do I index a cutting edge? When is a cutting edge in need for maintenance? And those needs to be not, I think, I feel, I suppose. It must be really objective indicators. And indexing needs to be done timely. Not, yeah, it will go for another workpiece, I hope. Because yeah, then the risk is that you crash a tool, and I already drew attention to it. So indexing needs to be done timely. Maintenance, how are your feelings about maintenance? Are you one of those people thinking to save some money and delay some maintenance? Or are you well aware of the importance of doing maintenance when it's due for? It's another major thing to take into consideration. And one thing people sometimes do not think on is, do you collect all knowledge you have about these things in your company? Because very often all this knowledge is in the head of people, but people tend to grow older and retire at one day. And then what? So is the knowledge stored somewhere? Indexing and maintenance, as I said, is for me an important thing. And everything is important, but here it's important because it's neglected so much. Inspection. There needs to be guidelines how inspection is done. Reconditioning. What do we do with reconditioning? Do we do a professional job out of it? Or do we, you know, the old way, I do regrinding myself a bit and it looks more or less good, so let's, or do we do it in a professional way? That quality is guaranteed. How do we store tools? How do we do the total reconditioning cycles altogether? Not just once, but over the total lifespan of a tool. And recycling, what are the guidelines for recycling? It's 5 things that are very important. Now, if you master total tool life, then you master the possibility that every single cutting edge is used with its full potential. And that will lead in the end to at the same time, higher productivity or shorter lead times, depending on what is most important for you, combined with lower costs. And that's what we do, or want to do. Now, tool life cycle management, there are 10 steps in the life cycle of a tool. And here I'm going rather fast because, yeah, this is, I suppose, I hope, well-known knowledge for everybody. But what we have to be aware of in each of those steps is that there are certain challenges. And we should know the challenges in a certain company. What are the challenges? And very important, if there is a conflict between two priorities, kind of, everybody should know which one has the highest priority. Which one overrules the other in case of a conflict. Actions needs to be taken care of, task needs to be done, who does it, who is accountable for it, when do we do it, how do we do it, and knowledge is needed. The last part, perhaps the most neglected one, because very often company management say, you do the indexing of the cutting edges when it's due for. But somebody needs knowledge, expertise, skills to know when it's due for. Step one. Before we start selecting tools, what are the strategic company goals? Because tool selection needs to be in line and not in conflict with this. What is it that you as a company want to achieve, want to be recognized for with your customers? Is it costs? Are you cheap? Or are you fast? Or are you good? Or what exactly is it that you want as a unique selling point, to use an old term? That needs to be done because in a second step, your tools need to be selected in line with that. If you go for high performance, you need high performing tools. If sustainability is in your highest position or priority, yeah, you need to think seriously about recycling or recyclable tools because that is a very important thing if sustainability is there. Which brands do you prefer? Which brands are helping you more? All of those strategic tool selection things needs to be decided, and this is production management. This is not the operator. I see so often the operator decide. The operator should not decide this. Management needs to decide that. The second phase in tool selection, putting technological features forward so that the tool as such is in line with, from a strategic perspective, we expect from the tool, so it's in line with a company strategy. That's for the technicians. Which carbide grade, which geometry, which dimension, all of that is then next on. Then tools need to be bought. Then you are in the purchasing environment. Then you are procurement management, purchase management. What strategy do we use there to order tools? What's the philosophy we use? What are agreements with suppliers we make, and so on? Perhaps I'm going to shock people again. In my eyes, purchasing departments should not select which tools, neither which brands. That should have been done before. That's my opinion. Then tools are bought, ordered, delivered, then tools needs to be received, checked, controlled, and put in stock. That's the next thing. When a tool is needed in production, then we enter the tool preparation and presetting phase. Tools need to be prepared to be transported to the machine tool where they are going to be used in certain applications. Then the tools are being used. Then we are in the typical machining environment we all are familiar with. After a while being used, there is somewhere that tools needs to be indexed, cutting edges needs to be indexed. Indexed means replaced because they are worn out. But as a certain tool can have more than one cutting edge, think on insert type tools. After a number of indexations, the collection of cutting edges, the inserts needs to be replaced. So it's indexing, replacement. Again here, this is something for the operator. But an operator should be well instructed so he knows when to do it. After replacement, the tools go back to the tool room. Tools need maintenance. And maintenance starts with inspection. Is this tool still capable of being used? Then I keep it. If not, then it's removed. And when approved for restocking, tools are restocked, put back in stock. If not put back in stock, then tools are to be recycled. Some tools are recyclable, other tools are not recyclable. Also, then we need to talk about what do we do with the tools then. Because another word for index tools is throwaway tools. I don't think in the present times throwaway is a good advice. We need to handle also the non-recyclable tools. So tool life cycle management is about defining and structuring a system. It's about aligning the whole system with company goals. It's about technical expertise there where needed. The people using the tools, indexing the tools have technical expertise. And it's about organizational skills. All these things we need. Now, if you say, this sounds interesting, in my company it's chaos, and I want order. how to proceed, because most people say, good, ready, we want this, we buy a software package, problem solved. I would say buying a software problem, I said software problem, oops. Buying a software comes at the end. First, we have to create some order. And creating order, if you do a logical approach, and here I go very fast, because, yeah, this itself, I can talk half a day about, but it's first about understanding what the goals are and aligning the goals. What are the strategic company goals? What are the strategic tool selection goals? How do we know what the present situation is what is important there. Next, we lay the foundations. Create kind of a tool database, standardized tool selection process, because there very often that's totally overlooked, the importance of it. So we first have to think about who selects tool, when do we select tools, how do we select tools. And I talk here from a strategic perspective. I don't talk about carbide grades here. I talk about which brand, which vendor, insert tools of solid carbide, that type of strategic thinking. We need to look on the ordering and inventory management system. How can we streamline it? And how do we receive tools? How do we store tools in general? Next thing is building. Building the processes, building the skills people need to function in this type of thing. It starts with training. And it ends up with setting up maintenance structures. And once we are there, then we can refine and make it sustainable. So kind of from a work methodology, there is a well-defined work methodology. If you say this tool life cycle management, I want to take it serious. I don't want to leave it at random. We see what happens. There is some steps to take. Start with small improvements, because a mistake made often is that people want to do everything at the same time. Don't do that. Start small. Take a point, make it work, use it as reference for the next ones. Do it incremental, step by step. And if it's small batch production, already here we should pay attention to versatile tooling, and a few words on versatile tooling. Because if we look to tool selection, and if I use the word versatile tooling or universal tooling, a lot of technical people, they say, oh, no. A versatile tool, a versatile tool is a tool that can do everything but nothing well. So that's not for me. I want good working tools. Now, if you still believe with that credo, that is 50 years old. Because in the meantime, tooling technology developed, and next to the traditional stuff where we expect all high performance from cutting tools, if productivity is important, or if we expect cost savings, economy from cutting tools, and that we say, okay, I want those tools who help me to achieve that economy. Or if we look for quality, if we say, no, I need tools that really assure me that the quality I need is not going to jeopardize during the operation. Technical people, they like that. Performance, cost savings, quality, all very nice things in big batch production. The fourth thing, versatile tooling, as I already said there, I don't know. Now, and I should add, next to these four classic things, nowadays tools are also selected in terms of sustainability, traceability, circularity, that type of stuff. But if we go back first to the classic things, high-performing tools, or flexible tools, versatile tools, it's two different approaches. A high-performing tool has the advantage that in one application it performs best possible. Whatever you define as best, is it time or cost or whatever. But if you have a lot of applications, then you need a lot of different tools. Each one being the best in its window. If you say, yeah, but the number of applications I have in my company is so wide, then perhaps in the picture here, the blue approach, you should more think in the window of applications of a certain cutting tool. And if you, and this is the kind of a mistake people make. They focus on one application then and they say, you see, the high performing tool works better. Of course it does. It has been selected for that. But if you look application-wise, versatile tooling gives you the advantage that with very little different tools, you cover a wide range of applications. First, a few words on sustainability and traceability, because everybody talks about it, but when you say people, okay, nice that you talk about, but what about making it happen? Then it's a bit vague, although more and more there are possibilities, because there is something which is called life cycle assessment. And life cycle assessment is an approach, it's a systematic approach to, throughout the true life cycle, you know, from selection to throw away, recycle, to evaluate how the total thing impacts the environment. That is what is referred to as life cycle analysis. And the advantage of that thing, which is a tool on its own, is that you can make objective things about emission tracking. What about the different stages in a tool? You can communicate better if you say my company's sustainability is an important thing, and your people in the workshop say, good, we follow you, what are we supposed to do to help you to gain that? Yeah, you need to communicate things to those people. And it gives you the possibility to maximize sustainability. Now, that's personally a word I like a lot, because we maximize cost, no, I should say we minimize cost. We maximize productivity, we minimize lead times, we optimize quality. Now, sustainability maximization is still a bit the vague thing in the picture, and LCA, life cycle analysis, I think is a major thing that will help us for that. By the way, next month there is a webinar on this subject on social media. If you are interested in this, I should say make sure you follow this, you can participate. Versatile tooling, as I said, modern tools are not the tools we had 50 years ago. And the main thing we aim for with versatile tooling is to improve OEE. You remember the machine utilization. If we can reduce machine setup time because we have lesser tools, if we can reduce downtime because lesser tools we know better and we control better, also that counts in the total picture. Lesser tools means reduced inventories, and that also saves cost. It gives you the possibility to have more consistent quality across different batches of workpieces, because very often if people, they have optimized tools for steel, and suddenly they need to do some stainless steel, they say, yeah, you know, we use the tools for steel, okay, it will work more or less. Yeah, that means that you have a good batch in steel, and the batch in stainless steel you had to produce, you have issues with. I call that an inconsistent quality across small batches. With versatile tools, you don't have that problem. Better total tool life. Total tool life, not technological tool life. Better utilization of tools. It's more flexible in production. There's less setup time on machines because there are lesser tools to be replaced between batches. Operator skills are this is a bit diplomatic. I don't say solved, but reduced. If an operator needs to know one tool, that's easier than he needs to understand 20 tools. So it's a diplomatic way. And please put it out of your head that versatile tools mean average or low performance. That is not correct anymore. That is... versatile tools, if you value production economy higher than peak performance in one application, I would urge you to take versatile tooling seriously. And you know, the number of successes of versatile tooling is enormous in the meantime. If you don't use it, believe it in small batch production, allow me to say you are running a little bit behind it from a technological perspective. Versatile tools, small batch production, it's brother and sister, it should go hand in hand, but you have to look further than just how many workpieces can I make with one cutting edge. It's much more about looking to the total tool life, the total picture. Clear instructions, clarity in instructions, that's where the whole system stands for. Telling a tool grip technician, yeah, if the tool doesn't look good, you should replace it. Don't put it in stock anymore. Okay, it's an instruction, but if I would be a tool grip engineer, I would have no idea how to evaluate a certain tool. So clear instructions is very important in every step nearly. Tool selection. How do we select tools? Everybody selecting tools in a company should know what the key criteria are. Usage instructions. How do we use the tools? And not find it out, try a little bit, you'll find it out. Handling guidelines. How do we handle tools? How do we work with that? Maintenance protocols. Yeah, replace the tool when it's worn out is really not enough. And communication channels in between. And talking about communications channels, there should be a standardized documentation set that everybody can consult to see what and how and when. Possible use visual aids. I know it's not of this time anymore, but posters are such an interesting thing to help people remind on certain principal things around tooling. Define very clearly operating parameters. Should you use cooling or not? What are the cutting conditions? When do you index and insert? All that type of thing should be very clearly defined. Maintenance, step by step. When do you check the spare parts? When do you check anvils? When do you check the basic tool holders? All those things should be specified. Do's and don'ts. Make sure you do this. Avoid to do that should be included in these things. Feedback. There should be a formalized way that people can give feedback. Use simple language. Trust me, I have seen instructions that I think, wait a second, let's sit down and try to figure out what exactly is meant by this now. One I remember was, if tool life is not longer than X workpieces, you should not index the inserts. Now try to figure out what exactly is meant by a sentence like that. Manuals, instructions should be updated. Things are changing, so also the manuals should be updated. They should be stored where they can be seen by everybody, where they can be consulted by everybody. Not somewhere in a cabinet. No, it should in the workshop, in the tool crib, wherever it's needed for. And handing out manuals also includes that you train people. If you don't know what a computer is, and I give you a manual 500 pages, here you have a manual how to work with a computer, yeah, good luck. There is some, next to the manual, education needed also. And I put this a little bit aside. If you start working with this, don't forget to collect all the knowledge you have in your company already. Talk to the older people. They have so much knowledge. Collect it and store it somewhere. Because everybody says, yeah, artificial intelligence, you know, and I agree. It's the future also in machining. But somewhere the system needs to be fed in the beginning with knowledge. And only then it needs to be raised, you know, like little children. And that needs to come from your old, experienced experts in the company. Clear instructions, actionable instructions, minimizing errors, increase performance. All of that is linked to how clear, how available are your instructions. And the last, the best people. Because it's people who are going to do the actual job. And if you want to go for a total tool life cycle management structure, a total tool life which is maximized through it, this involves everybody in the company, from company management through production management, purchasers, logistic people, maintenance people, tool room people, operators, foremen, everybody is involved in this. They all have to work together and they all have their little task to take care of. And it's always good to have kind of a group of people having an overview of, especially when you are in the phase of building it, kind of a group of people guiding the company through the process. And important is that, as I said, company management is involved in this, and the operator and the tool room technician is involved in this. Well, all of these people, all of these steps, layers, whatever you want to call it, should have a place in the committee, should represent the knowledge, the skills, the expertise the company have in that stage, and build together with all the other people the one big picture from where it is going to start then. It's important to have a team. Interesting is that at least one from general management is there, somebody that has the authority to oversee everything and to take company strategic decisions. And it's always good also to have somebody with not personal involvement in daily stuff, an external person that can be the objective helper that is loose from any politics in the company to give advice on what to do, how to do, and when to do. From the beginning, it must be important that part of the job is empowering operators and technicians to do things, because it's their daily actions that will make it happen. And to make sure that is well done, training programs, clear procedures, visual aids, feedback loops, all of that needs to be thought out, needs to be installed, needs to be taken care of. People should have the possibility to exchange experiences on a regular basis. You can introduce daily or weekly pulse meetings, you know, to feel the heartbeat, the typical shop floor meetings with the people involved there to talk about what's going on, what is working, what is not working, on a regular basis, monthly for instance. The steering team should meet to review if something happened in the company KPIs, if that has an influence on what we do with tooling in the company and so on. And on a quarterly basis or a 6 months basis, a bit depending on the situation, there should be management review meetings. To see, okay, is what people are doing from a tool lifecycle management perspective still in line with what we want to do with the company? And if not, how to act, what to do. And important, and I put the last line here a bit in blue to draw your attention, a very important thing, because people think on everything from management perspective, the future software we are going to use and the restructuring and stuff. But what about rewarding and recognizing people for the work they did and they are going to do in the future? And I'm going to come back to it because here you see it. I think everybody making an effort deserves, in whatever situation, you know, it can be privately or professional, I don't care, but everybody deserves recognition and deserves, when appropriate, a reward for what he or she achieved. And I call it a reward. It doesn't need to be money, just a reward that shows recognition. Even soldiers receive medals after the battle. And that needs to be done timely and transparent. Not by the end of the year, you know, we are in January. By the end of the year, who knows what I did in January? So it should be timely, it should be transparent. Start with a small project. You have a team, you have some people. Inform everybody about what the intention is, and start with one machine, a group of machines, one workshop if there are different workshops, whatever. Start small, create a success, and build further on it. And from the beginning, I think you should integrate vendors and suppliers. You should integrate them to inform them about what you are doing, but you should also integrate them to exploit, to take profit of their knowledge, their expertise, to help you train and educate your people in whatever skill they need to control a tool life cycle. And somehow foster a culture of ownership. You know, that people feel I'm the owner of this, because if people manage to have good tool life, being it technological or total, that equals company profitability. And if you can have daily discipline in tool life cycle management, that means production excellence. So the daily work of people, if they feel responsible, accountable, and in the end your target production excellence, however you decide it, it's linked together, you know. Encourage that your people realize that any tool is only as good as the one handling it. And a well-handled tool is the foundation for production excellence in a machining workshop. Everything is connected. Everything needs to be in balance. The selection, the uses, manipulation, indexing, whatever step in the total thing needs to be taken into account. Central here are clear instructions to everybody, so people know what to do and when to do, and you need skilled people to make it happen. And especially, as I said, in small batch, small series production, this is going to help you so much to have your production excellence. Every phase requires a combination of managerial, strategic, technical, and operational knowledge. So it's not an easy thing. You need to bring all of these things together, and instead of that people are fighting each other, you have to make them work together. And everybody should bring his or her skill, expertise in the total picture. Very short, because this is, as I said, such a big subject and an important subject. But anyway, short, but I hope it made sense. I hope I could let you feel how important tool life cycle management is. And I hope I could give you some ideas if you think, now, we don't have that really, and we perhaps should think about it on having it, how to handle, what to do, where do I start, that I could give you some ideas, some things you could start thinking on and yeah, reflecting on. Before we end, because we have some time left, let me see if there are questions. There are a lot of questions, so we will have to be selective a bit. One question is from Fahim. He wants to increase tool life of hot forging dies. I suppose he's referring to technological tool life. He's asking for help. Yes, help is available, but in this context here, during this presentation, yeah, I cannot say do this, do that. What I propose is that we come back to it afterwards and that we see what exactly you need as help. Is it about strategies or what are we talking about? Then I have another technological question, and yeah, again, I want to take that. All the technological questions I see here, I want to take in separate answers. Then there are, what do you see as the biggest chaos creator in tool life cycle? The biggest one. I think the biggest one is tool selection. Because as I said, as from the beginning, you start with the wrong tools, the wrong philosophy, the wrong suppliers, all the rest falls apart. Huh? I would say if you think, the photos I showed in the beginning, if you think, that looks like my workshop, I would start with having discussions on tool selection procedures. Who, when, where, based on what is the strategy, how do you select, and create some order there. First start cleaning before structuring. I think tool selection is the biggest chaos creator when we talk about tool lifecycle management. Yeah, and then there is another question, do I have to answer that? Who has highest priority in the decision process? Which tools, I suppose? Production or purchasing? Whatever I say, I'm not going to make friends with everybody, I think. Personally, I think the basic selection of a tool, the features of a tool should be production, but how that tool is handled from a purchasing perspective, that is purchasing. Because the targets with purchasing is to make sure that tools are there when they are needed for, and at the same time that there are not too many tools there and not the wrong tools. So it's not about priorities, it's about, it's two things. Production decides which one, and purchasing decides the commercial approach on how are we going to make sure these tools are here in our company in the correct quantities and quality. So it's not about who has priority, I think. Where are the biggest gainings possible? Yeah, that is easy for me. That is in maintenance and storage. See the photos I showed you, in all the projects I had, in all the workshops, wherever in the world, in average, my idea is that using the tools is rather well managed, but everything around the actual using, that is kind of a bit neglected. So I think the biggest gainings, instant gainings, direct money in the pocket, money on the bank, is in maintenance and storage. You only ask difficult questions, or dangerous questions, and still some time left. Where is the best place to do tool pre-setting? Who is the best person to do it? Yeah, I know in a lot of companies there is that eternal discussion, should tool pre-setting be done in the tool room, if there is a tool room, or the tool storage, or the tool crib, whatever you call it, where all the tools are collected. Should people do the pre-setting, or should the operator do the pre-setting? Because there is kind of a mistrust between those people, you know, because an operator knows how important it is to have accurate tool pre-setting, the length and the diameter and the whatever you need for a tool as data around it. Because if something is wrong and he starts using the tool, he's going to crash the tool. And guess who is going to be accused then? That's the operator. So what I see in a lot of companies is that both are doing pre-setting. And that's a waste of money and time and efforts. They do pre-setting in the tool room, and then the tool arrives at the machine tool, and the operator checks again the tool pre-setting, just to make sure, you know the story. I think it's an important thing if you talk about tool lifecycle management, because tool pre-setting, tool setting is an important step in the total picture, and you should put people at the table and arrange that both groups, both teams are aware of the concerns of the other and can work together there, because doing two parties or having two parties doing tool pre-setting is a bit, a waste of time and money. One last question then. How to make versatile tooling a successful choice? Well, it starts by recognizing that by definition versatile tooling is, from a quality perspective, from a technological perspective, as good as whatever other type of tooling, but you have to use it in its strength. And the strength of versatile tooling is not to look in one application only and compare it there with other tools. The strength of versatile tooling you have to see in the total tool life cycle. And if those two things are clear, that you need to have another view, not one application, but all applications, and that the performance of a tool is not defined. Let's put it like this, the performance of a tool is not defined in number of minutes technological tool life. The performance of a tool should be evaluated in total tool life. And only then you can make a fair comparison. And the other questions, let's agree here that the other questions I take later in the comments and handle there, because I see quite a lot of technological questions still. You hear me say quite a lot of times here that skilled people, knowledgeable people is important. Perhaps that should be your first priority if you really want to do things with tool life cycle management, that you make sure that all parties involved from a people perspective receive the needed training, education, so they have the correct skills or whatever to do their job. I think it really starts there. I want to stop here. I'm already over time. Sorry for that. I want to stop here. Remember, in February, there are here in Seco, Germany, there are the ITI days. Very interesting if you are in travel distance from here. It's always nice to have a talk and have a look on what's going on in the tooling industry. Thank you. If you have other questions, if there are other things you want to talk about, send an email to Alesia or to me. And I promise you on behalf of Alesia and myself that we take care of your questions in the earliest possible way and make sure that there are no loose threads anymore about this subject. Next month, remember if the LCA thing, the life cycle analysis from a sustainability perspective, if you think that's something I want to hear a little bit more about, keep your eyes on social media. It will be announced shortly how to register and where you can register. Thank you very much. I hope it was of interest. If more questions, remarks, or if you want more information, don't hesitate to contact us, and we will be back to you as soon as possible on your questions. Thank you very much.